Hello, everybody, and welcome to another episode of our Video Analytics 101 podcast series. Today, I have Professor Snoek with me. He is a full professor for computer science at the University of Amsterdam, and he also heads the Video and Image Sense Lab there. So someone who is super deep into computer vision and AI in computer vision, has been working on this for many years. He holds other positions as well. He's a very busy man, and that's why I'm super happy that he takes the time today to talk to me. Welcome, Cees. Welcome to this podcast.
Thank you, Florian. Thanks for the nice introduction and glad to be here.
Yeah, it's very interesting to talk to a professor who is really in computer vision and holds so many positions in so many different places to get a little bit deeper into computer vision on the academic side and how it relates also to other labs and startups and so on. So I'm sure this will be interesting. But first off, maybe can you introduce us a little bit to yourself? What's your background? How did you get into computer vision? And I'm personally just interested, what do you find exciting about this field? How did you get into that?
Yeah. Well, so maybe let's start with what triggered me to go into this field, and I recall this very vividly. So I was a student at the University of Amsterdam, studying technical information systems, and at some point I was in a course that was called Image Information Systems, and the lecturer there showed a system for video analysis that was from Carnegie Mellon University. It was called the Infomedia system. And what these guys did, and this was already in 1995 when they started this project, they were analyzing television broadcasts from CNN network, so news broadcast, and they would provide all kinds of analysis of these video streams to make it accessible for users. And one of the things that they also had was face detection, where they could localize the face with a box around it. And when the first time I saw this, I thought this is magic. And
this was just the time around Viola Jones, right?
No, this was the Rowley face detector back in the days, and also the follow up. And I was essentially, I thought it was magic, so I wanted to understand. And that's essentially how I started. So then the same lecturer also had a master thesis topic related to video and detection. So that appealed very much to me. So I picked that for my master thesis. Did a decent job, so I was offered a PhD position, which was essentially the next step in this trajectory. So I took that, and that's how I got hooked, so to say.
What were the topics in your master's and PhD?
So the topic in my master thesis was to estimate the distance of a camera in feature films. So during recording, can you estimate how far is the distance from the subject? So that was the topic of my master thesis. And in my PhD, the topic was essentially, can you analyze video from a multimodal perspective? So not only the computer vision, but also related audio and text. And what can you infer from what happens in the content?
Okay, cool. It's funny because I did my bachelor's in video computer science, and after my bachelor's decided that it wasn't technical enough. I liked the this media part, but it wasn't there was not enough maths. For me, the reason to switch to computer vision is because it combines this visual aspect, as you say, it's magic.
Yeah.
But it also has a lot of math. So this technical background, I find this pretty cool.
Yeah. No, definitely.
So you did your PhD, then I guess you became a postdoc at one point, and then went to professor.
Yeah, and what was also nice, when I was a PhD student, I was also offered the opportunity to visit Carnegie Mellon University to actually work with these guys from this Infomedia system. So that was also an enormous boost for enormous encouragement, right? Because it's something that seems so far away. All of a sudden, you're in the midst of it, and that is the nice part of academia, that you can really quickly work with the people you admire, so to say, and be inspired. So yeah, that encouraged me a lot, and also then to do a follow up as a postdoc and assistant professor, and yeah, and full professor eventually.
Okay. Yeah, I fully agree. I'm not in academia, but I always like how you can really meet the people that are so big in the field just in a regular conference and have a coffee with them.
Yeah,
It's
yeah,
really cool.
yes.
Yeah, so what are you currently working on? Are there any interesting projects? I did a Google Scholar search or some other paper searches. There are tons of papers with your name on it.
Yeah.
Do you have a few interesting ones that might be interesting for our audience?
Well, so I've been so from the start of my my journey, I've been fascinated by video and trying to understand what is happening where and when in video. So that is still a strong part of my research agenda. So initially, I was inspired by video, so that has always been a stronghold in my research portfolio. And well, as you grow more senior, the portfolio expands, and also the number of students you supervise expands. So also the number of topics expands. And I think a common theme in my research, well, the name of my lab is Video and Image Sense Lab. So trying to make sense of video and images, that is sort of like the common theme. And another common theme
Mhm.
is to always study things that optimize for use in the real world. So I'm also
Mhm.
looking at making computer vision more practical in that sense, right? So topics like learning from limited examples, so that it
Mhm.
becomes more useful for general audience. Other topic of recent interest. So learning from few examples means topics like self-supervised learning, meta learning. Another topic that is of interest is how can we generalize. So we train on some type of data set, and then we want to make sure it's robust in different sets that are slightly different from what you have seen at training time. Can you sort of like increase robustness during these settings? That's one. Of course, we're also interested in transformers. So not just applying transformers, but making them sort of including inductive biases that are natural for computer vision that you won't see in natural language processing, for example. So in natural language processing, you don't have the notion of a region, right? Or the notion of space time. So how can we incorporate these in transformer architectures to sort of like make them more compute efficient and robust for visual data?
I find I find it very interesting because yeah, the field is really driven by NLP for a long time. And
Definitely.
as you're saying, computer vision is very different. And yeah, I totally get that a lot of methods do not apply to computer vision, that do apply to natural language processing.
Well, the surprising thing is nowadays that the field doesn't matter anymore that much. So we used to call ourselves NLP researcher or computer vision researcher or machine learning researcher, but nowadays it's all the same. It's all the same machinery, and there's small nuances that make the difference.
Mhm. Yeah, interesting. Um, Maybe a follow-up question to this. How relevant is in your space generative AI? I mean, that's definitely a revolution in the NLP space, but also towards images and videos. It's not so much in my area yet in the security industry, but I'm wondering how much on the research side is being done on computer vision generative AI.
Well, it's a lot. So it is a very
Yeah.
hot topic. It's a very interesting. So we study it as well. There is one big limitation to generative AI in an academic setting is that the huge amount of compute it requires.
Mm.
So this is a topic where in academia it's very hard to compute with the big tech industry labs, not because of lack of ideas, but simply lack of compute to be competitive. So, and this
And
is sometimes
how do you deal
frustrating.
with that?
Yeah, this is frustrating. So how we deal with that? So well, we're trying to get more and more compute access in Amsterdam, the Netherlands, and also in Europe. But this is hard because there's simply not enough uh, available to us. So working on this, we try to collaborate with parties who have a lot of who have more compute. and we try to pick other topics that are not in the huge compute space.
Mhm.
But this is somewhat. So the frustration here is that you can make a lot of impact in this area, but you need a lot of compute.
Mhm.
So automatically your impact will
Yeah.
be.
It's also an interesting budget question because I mean, it almost needs unlimited budgets in terms of academic budget. So it's pretty hard for states to finance this as well.
Yeah, and you need the latest and greatest GPUs. So of course you can buy them. My lab has actually quite a lot of GPUs, but you also need to you need a lot of them, and you need to refresh them every 3 years. So it's a
Yeah.
lot of money that you need.
Yep. And you need the staff for it as well. I mean, this is
Exactly, to
not only a
maintain
money question.
Yeah. So that's
Okay.
a challenge for present day professors in computer science in academia.
Yeah, there's a professor in Austria who complains about this very topic, and in general that Austria, where I'm located, is not funding AI at all, or not
Oh,
enough,
is this
and
Sepp?
this is part of the problem.
Is this Sepp
Yes,
Hofreiter? Yes, I know him very well. Yes,
yes. Well, I think everybody who met him knows him very well. He's very vocal.
yes, that's true. He's also a very nice person.
Okay, yeah. Okay. I wanted to get a little bit of an idea of how big of a role does machine learning or AI play in the computer vision field? I mean, it's not synonymous. Computer vision is not AI. There are processing methods as well. But obviously, with deep learning and the papers in 2012, it changed a lot. So, how much do you say today is really AI in your field, and how much what role do classical image processing methods still play?
Well, so since the ImageNet moment with AlexNet, I think computer vision has changed drastically. So before 2012, getting a paper published with neural networks in computer vision was frowned upon, was really hard. And
Hmm.
nowadays, it's almost impossible to write a paper without neural networks.
Hmm.
So the field has changed drastically. I mean, essentially, what happened after 2012, all my lecture slides that I would present to students in class were outdated, and I had to start from scratch. Right? So
Hmm.
imagine working for 12 years in an area, and then all your legacy inheritance is basically obsolete. So that's what happened. And I would even say that many of our present day computer vision students are essentially machine learning researchers,
Hmm.
but focusing on experiments on image data.
Hmm.
And the large majority has no or limited knowledge of more classical signal processing and image processing know-how. And this is a pity because, of course, there were smart ideas back then too, and this will come back. But yeah, we are now in the midst of a machine learning. Everything is machine learning, essentially.
Yeah. Okay. Yeah, and I mean, obviously, it delivers much better results. And it's not only the networks and so on, but of course the compute that changed so much. I remember I was in a robotic lab where they were experimenting with like sifts or some kind of features,
Yeah.
and it worked kind of well, but it was unimaginable that a computer would be able to do this efficiently and in real time. It was such experimental thing back then, and nowadays it's so normal.
Well, what changed? I mean, Sift.
Yeah.
We had Sift, and we had bag of words and feature vectors and all that, and support vector machines. And we could do ImageNet also pretty well, actually. I mean, also before AlexNet came around, the results on ImageNet were not bad. You could even start a business based on such a pipeline. And it was also very hard to replicate because there were no open software packages where you could easily sort of like try this. So if you were a student, it would take you a year and a half to replicate such a pipeline, and then you would be miles away of the state of the art because progress continued. So the big breakthrough of deep learning is also the uptake by industry and the facilitation of making software available so that it was very easy to run your ideas. I mean, if you were a student in Africa or in Asia without much infrastructure around you, right, or much expertise, you could easily study a topic yourself, run the software, make an improvement, and write the paper. So that has really sped up the speed of research.
The availability of data sets as well. Back
Yeah.
then, there was just not so much, and with Google and ImageNet, it's exploded.
Yes. Well, ImageNet was already there before deep learning.
Oh yeah. Mhm.
Yeah.
Okay. Yeah, I wanted to talk a bit about the startup you're involved in. It's a spin-off from the university called Kepler Vision Technologies. You're a chief scientific officer there. Can you tell us a little bit about what the startup is doing and which field and what problems it's solving?
Yeah. Well, so Kepler Vision works in the healthcare domain, and so what we do is in elderly care we monitor patients in their rooms, and we send out alerts to the care staff when there is reason for an alert. For example, because somebody has fallen or is sitting on the bed during the midst of the night, or spends a lot of time in the bathroom. So we sort of like analyze unwanted or worrisome behavior. Let's put it like this. And
Hmm.
once it is signaled, we send a text message to the nursing staff, who can then inspect on demand, so to say.
And essentially, you're optimizing healthcare. So I always hear there's a crisis of staff in healthcare. So you're trying to automate some things so nurses can focus on something else again, I guess.
Yes, and it's also there's also a lack of staff. So finding sufficient people to take care of the ever growing amount of people who need care is getting harder and harder. So in that sense, it also relieves organizations in finding personnel, and it also
Hmm.
helps the personnel that is present to focus on caring rather than checking and inspecting. And what is the biggest advantage of you working with optical sensors in this sense, because there are many solutions and sensors available in elderly care and in care in general, is that optical sensors, at least the one that we use with Kepler, is making a really few false detections. So other sensor solutions they alert all the time, so the nursing staff becomes sort of ignorant to them.
Are these some kind of special optical sensors, or what is that?
These are just regular cameras, normal view and fisheye view cameras that are already in care facilities, and our software runs on these cameras and alerts to the regular nurse calling systems, and tells them, look, on your phone there is an alert in room 101, go have a look.
Okay, I could imagine that this kind of technology only was made possible in recent years because some kind of these applications I've heard for many years, but as you were saying, they used to trigger a lot of alerts. So I guess in recent years it became much more accurate and more efficient, so you can actually use it.
Yeah, so the recognition accuracy has become much more reliable and robust, and also the efficiency of the computation has increased. So you can now run it essentially on the camera, so on the edge. So no need
Hmm.
to have huge compute facilities available.
Yeah, that's important in practice as well because I mean healthcare providers nowadays they're big enterprises, but still they're not the kind of enterprise that have so much IT knowledge. So the more
True,
you can make it
true.
easy and plug and play, the better, right?
Yeah. No, this is true. So healthcare is a very conservative market technology wise, I would say. But I mean, it's becoming clear at least for the Netherlands. I assume it's the same situation in Austria and other countries in Europe. Is that the way we have been managing healthcare and funding healthcare from government side in the past is no longer sustainable. So things really need to change. And well, this is being realized by the people who manage care. So this is it's a slow process, but it is coming and it is inevitable. So technology needs to come to the rescue.
Yeah, I think this is a good example of the good that AI can do, where it automates things to make it more efficient. It doesn't take away jobs. It just makes the life easier of the people doing the jobs, really the
Exactly.
lives of everyone. Yeah, it's a great application. I mean, one question that, of course, I'm asking myself is cameras in healthcare might be a privacy question. How do you deal with this, that you have a camera in a patient's room?
Yeah. So well, so in Europe we have laws, and actually Europe is on the front in the world on how to handle privacy. And the nice thing of our solution is that we don't need to store images. So we process an image on the camera, and all it then does is send a text message to the nursing system. So nobody has to look at any image whatsoever. Of course, we can make our software better, and sometimes we also want to understand, hey, why was an alarm triggered, or why was it not triggered? And then we can still look at images if this is negotiated with the facility, right? So if they have stored it, and then what we do is we always store any image with blurred faces, so identity is not observable.
Okay, makes a lot of sense.
Yeah.
Have you experienced with patients how they feel about this? Like, I mean, on the technical level, of course, privacy is protected and clear, but I might imagine that there's a psychological aspect there as well.
Yeah. Well, this is from hearsay because I'm not involved in the sales and daily operations of the company. But what I've been told is that often the elderly patients themselves are very much in favor of having
Mm.
such a solution, such an optical solution in their room, and that often the children are more concerned,
Oh, interesting.
right? So that they feel, oh, but what about privacy and
Okay, interesting.
yes,
It's
I thought that was interesting
I had a
too.
month ago. I had a month ago a conversation with Matthias Uhl. He's a professor for ethics in AI, and they did a similar study around robots in healthcare, where his big thing is he wants to really ask people and get feedback of the people involved and actually affected of technology and concepts, and not think about it from a theoretical philosophical level. And he also had interesting findings because on a theoretical level, philosophers in general in this space are saying, yeah, we are dehumanizing healthcare, robots cannot provide the same, and so on. But when they actually did the study, they found out that people are very grateful and they want this because they get better care. They know
Yeah,
that this helps them and it's a tool for them, really.
yeah, exactly.
Hmm. Yeah, well, very interesting technology for sure. It's a spin-off from the university. I've been involved with this topic myself, and I know it's being dealt with in different ways. Of course, in the US, the UK, in Europe. How is it in the Netherlands? Like, if somebody has a great idea in the department, how do you start a spin-off from a university?
Um, yeah, so I mean, my experience is limited to the University of Amsterdam in dealing with university and starting a spin-off. I know that different universities in the Netherlands have quite different policies, and also in terms of ownership and taking stakes in businesses. And I must say that at the University of Amsterdam, this is very well arranged. That also has to do because we have already quite some experience with now with software startups. So
Hmm.
let me see. In 2010, I was involved with another startup spin-off from the University of Amsterdam, and at that time, the university had basically no experience with the software companies, how that worked, and how to make that profitable, and what are the sort of like the how IP works in tech, and I mean, they had a lot of experience with pharma and medicines and protecting this and making a business out of it. But with software businesses, they had basically no clue. So I think the university is a learning organization, so they have learned a lot from these experiences. And I would say that nowadays the University of Amsterdam is very supportive and is even funding also spin-offs if there is a match. Yeah, so I would say it is well arranged and there's a lot of support.
Does the university have stakes in the companies?
Yeah, so that depends, and that is negotiable, right? And of course there will be initially some there can be some stake, but not too big. And yeah, if they invest real euros, then the stake will be bigger. But that is something that you can with the founding team can decide. So they become an investor rather than only somebody who takes shares.
Okay, yeah, that's interesting.
And I think that is that is wise, because if the university would only take shares and leave it all to the founders to make something out of it, that is not very motivating.
Yeah, and also it depends on how much shares they take. I've recently seen a study that if universities have a controlling stake, like more than 25% or so in the company, then the likelihood that the startup gets a Series A VC round gets dramatically down, because VCs are afraid that universities will say what to do and so on. So there's a balance there that you have to take something, but not too much, so you don't
Yeah.
kill it later on.
Yeah, no, 25% seems like a lot, so I would do less.
Yeah.
Yeah.
You're also working in other institutions and I think in private labs as well. Yeah. So first of all, can you share a little bit what you're doing there in the labs? Is there something interesting that's not secret that you could share?
Yeah. Everything that we publish is not secret. So we have, these are not private labs; these are public-private labs. So these are
Okay.
collaborations between a private company and the University of Amsterdam. So you could also see these as big projects in that sense. And I'm involved with 3 of those labs. One is with Qualcomm, the American mobile chip company. One is with TomTom, who is in the business of map making. And the other one is with an institute from the Emirates, an institute on artificial intelligence, where we work on medical imaging. Yeah, so we publish a lot of topics. So I mean, recent publications from the Cuva lab are on self-supervised learning a lot, and also causal representation learning is done by a colleague of mine in the lab. We are working in the TomTom lab. We're working on, for example, on object detection, so localizing objects in 2D and 3D space, so that can help with interpretation of map data. And in the medical imaging lab, we work a lot on learning from very few examples, because data in medical imaging is scarce. So what can you learn when the number of examples are very low? And we also work on generalization. So what if you train a model that is learned on a certain MRI scanner in hospital X? How would it generalize to data acquired by such a device in hospital Y? Right, so without
Interesting.
again. So these are sort of like some of the general topics we do. We also do multimodal learning. So what can you learn from multiple modalities? So not only images, but also audio.
Do you see a difference working with private organizations versus academia? Is it a different way of research that you have to do?
No, actually, I would even say that so when I apply for funding in the National Science Foundation in the Netherlands or in Europe, I would say that is typically even more applied than the research I do that comes from these public-private partnerships.
Hmm.
The reason is that in these joint labs, the goal is not to create a product, right, or to create a demonstrator, because they have their own department for product development. That we are not good at that at the university, right? So what they want is they want to have new knowledge that relates to their field of specialization. So also to create new IP and to also transfer the knowledge to the engineering department from the company itself, so that they stay up to date while also having influence on research. And last but not least, also to sort of like advertise to the world, look, my company is very interested in state-of-the-art AI research. When you're done with your PhD, come work for us. So it's
Hmm.
also a
Yeah,
matter of getting the talent.
I could imagine that on the other way around, it's interesting for academia to get real world use cases and data sets and trying it out in the real world. Is that interesting?
Yeah, but getting data sets from companies is very hard, and so they are
Hmm.
not very eager to make this available because they don't want this to be shared and all kinds of things. So that is typically not the way we collaborate. It is more like this is the general topic we are interested in. Can you innovate the state of the art on this topic and transfer the knowledge back to the company and maybe protect it with patents that we then also hand over to the companies?
Okay, so part of it is being patented, and part of it you can publish in
That's an
academia.
op that's no. So everything is published, but you
Ah,
can
okay.
patent it before it is published. So no,
Oh, yeah,
we
yeah.
don't. Yeah, we are a university, so everything we do is open and transparent and will get published. But the companies have the right to, before we publish it, to protect it.
Okay, interesting. Okay.
But publication will always
So I
happen.
guess this model will become more and more. Yeah. I guess this application will become, or this partnerships will become more and more as the field of AI grows and the commercial interest grows in this field.
Yeah, we had our first collaboration was with Qualcomm, which started in 2015, and then colleagues of mine had another such a lab with Bosch, the German engineering company. And then at some point we thought, hey, wait a minute, maybe we have a template for these kind of collaborations.
Hmm.
So we started more, first in Amsterdam, and now we have about 50 of these labs in the Netherlands, all
Oh, wow.
across the Netherlands with different universities. And yeah, one of my colleagues at the University of Amsterdam is heading this national effort. So it has really
Okay.
expanded as a good way to do public-private collaboration in the AI space.
Hmm. Um, yeah, speaking about AI in general, maybe to round all this up, it's becoming super hot right now. If there is somebody like a young student going in this field today, is there a specific area of AI where you would say this has the most future, that's the most interesting, or is computer vision even the best place if you want to do AI? What would you recommend a young student?
Well, so I think there are two very interesting topics in AI at the moment. Well, the first is technological, and one big topic of interest in technical AI is this notion of foundation models. So this models of models that basically you train it once on huge amounts of data, and it can essentially solve any task with only a few amounts of examples. That is a super interesting area of research. And the other dimension is more societal. So, what is the impact of AI in society? I mean, in AI, we have been sort of like over concentrating on getting recognition ability better and better over the years, and we have sort of closed our eyes for all the bad effects that AI can have when it works really well, right? So, also
Mhm.
abuse. Um, so um, so this human alignment of AI is also a very interesting topic, and not only by regulating it after the fact or talking about ethics once the solution is there, but incorporating it from the start. So sort of like building it in.
Yeah. I, this is something with trustworthy AI that the EU tries to get ahead
Exactly.
of as well.
Exactly. Exactly.
Um, but I'm always looking at I mean, first of all, it's great what the EU is doing, and the AI Act is probably the first one in the world, maybe after China, because we already passed it. But it's still interesting to see that they started the process 3 years ago, and it's still not passed. And 3 years is the world in the space of AI. So we will
True.
never catch up with
True.
technological reality. So I think in addition to the framework, the legal framework, we need this conscience in academia, but also in enterprises that we need, as you're saying, we need to build this in from the start, even
Yeah.
if we're not required to, but we need to do the moral and ethical right thing.
Yeah. And so what's happening is that AI is no longer a technology only field. So all other fields of science will want to use AI or have an opinion about AI. And I think this is very interesting because it basically creates all kinds of new possibilities. So I'm working with Marie, for example, Marie Lindegaard, who you interviewed before, a social scientist. So she's looking at video footage by manual inspection, and she asks very interesting questions that we can definitely not solve automatically, but there's a huge collaboration potential, and you can sort of like make social science much more empirical and exact. So that is a potential revolution in that field. And I
Yeah,
believe that
absolutely.
any discipline at the university can probably profit from AI.
Yeah, I think so too. In the end, it's a technology and a tool. It's not an end by itself. Sometimes in our industry, it's we have some explaining to do because customers might come to us and ask, "Do you use AI?" And if I say yes, it doesn't help you.
Yeah.
You need to ask, okay, what's your problem? And then we can see, can we solve this with AI? And I
Yeah.
think the same way we can revisit a lot of problems in many fields and just revisit them where in the past it wasn't possible. Just go there again and say, hey, is it possible now with AI? And likely it
Exactly.
is.
So this is, I think, very interesting for students who aspire to change the world and jump in this lacuna, so to say, where you have two different disciplines that don't really talk with each other, and AI can be sort of like the glue and to make a change. So I think that is very interesting.
Okay. Okay. Well, that's and very inspirational final words. Do you have anything else that you want to share before we end this podcast?
No, I think I said anything I wanted to say.
Okay. So yeah, let me just repeat what you just said. Get into the field of AI. It's world changing, and it could be that you are using AI as the glue between different disciplines that solve real world problems. I think it's very visionary and inspirational and very cool. And I hope it inspires new students to go into this field.
I hope so too.
Thank you, Case, for joining. Thank you for talking to me today. It was very insightful to get a little bit into academia and AI. Very cool. Thank you.
Thanks a lot for having me. Thank you.